Welcome to qnawire.
Hello friends, as shown in the figure, there is a pin B having the weight 4 ounce and is free to slide in a horizontal plane along the rotating arm OC and circular slot DE of radius 20 inch. Neglecting friction and assuming that angular velocity is 15 radian per second and angular acceleration is 250 radian per second square for position theta to be 20 degree. Calculate radial and transverse component of resultant force exerted on the pin V, and in second part we have to calculate force P and Q on the pin V applied by the rod OC and slot DE respectively. Let us start solving it. Using the geometry, we can write R can be defined as 2V cos theta. So derivative of R can be defined as minus 2V sine of theta into theta dot. If we find the second derivative of it, you will get 2V second derivative of theta into sine of theta plus square of single derivative cos of theta. So we will get radial acceleration is double derivative of r minus r into square of single derivative of theta. Substituting the value from above, you may write minus 2b theta double dot sine of theta plus theta dot square cos of theta minus 2b cos of theta into theta dot square. So on solving it, you will get radial acceleration to be 2b negative double derivative of theta sine of theta plus 2 square of single derivative of theta into cos of theta. Substituting the value, you will get 2. That is V. V is given 20 inch, so 20 by 12. Theta double dot having the value 250 sine of 20 degree plus 2 into 15 square cos of 20. So this value you will get 1694.56 feet per second square. And transverse acceleration R into theta double dot plus 2 R dot theta dot. Substituting the value, 2b cos of theta theta double dot plus 2 minus 2b theta dot sine of theta into theta dot is equal to 2b theta double dot cos of theta substituting the value you will get transverse acceleration 2 into 20 by 12 angular acceleration having the value 250 radian per second square cos of 20 2 into 15 angular velocity square so 15 square sine of 20 so you will get transverse acceleration 270.05 feet per second square. So first part radial force mass into radial acceleration mass is given weight is given so it has to be converted into mass so 1 by 4 pound divided by 32.2 feet per second square into radial acceleration minus 1694.56 feet per second square so it would be minus 13.1565 pound. Now similarly we can find transverse force mass into transverse acceleration so it is 2.0967 pound so we can write transverse force to be 2.0967 pound. Now we have to draw a free body diagram of the block. This is the direction of transverse force. This angle is 20 degree. This is the radial force and this angle is given 20. Here it is Q which is 40 degree. In this direction it is P 20 degree. Taking summation of forces along radial direction it will be minus Fr is equal to minus Q cos of 20. So Q will be F R upon cos of 20. So value of Q we will get radial force is 13.1565 upon cos of 20. On solving it, you will get 14.009 pound, and taking summation of force along transverse direction, transverse force is equal to P minus Q sine of 20. So P is equal to, you will get transverse force into Q sine of 20. Transverse force is 2.0967 plus 14.009 sine of 20. So on solving, value of P force you will get 6.89 pound. So answer of B part you may write force P having the value 6.89 pound in the direction up along the horizontal line by 70 degree, and Q 14 pound down to the horizontal line by 40 degree. That's all for it. Thanks for watching it.